And thanks everyone for coming. Hope this is going to be fun. I sometimes have a tendency to speak too fast, so if I do, let me know to slow down. Do we have an hour or so?
Yeah, you have as much time as you need.
As much as I need, so let's go on for 3 hours. My name is Philip. I work at SOASTA. It's a company that works in the web performance field. I specifically work in real user measurement. SOASTA also does load testing and functional testing for mobile devices. I'm the author of a JavaScript tool called Boomerang, which I built while I was working at Yahoo to measure the performance of Yahoo's websites. And a lot of the research that I did at Yahoo and from then onwards, some of that ended up in what's called Yahoo's performance best practices. So if you've ever visited developer.yahoo.com/performance, I wrote some of that HTML. And today I'm just going to talk about some of those rules, how they've changed, new rules, and essentially try and get you to a crazy level. Who here is a beginner in web performance? Excellent. So we're going to start off with some. So front-end performance beginner. That's where we hope. Well, if you're at that level, we'll try and get you to the next level and beyond. Who's an expert? Who considers themselves an expert? Who considers themselves crazy? Yeah. Alright, so the idea of web performance, of being a performance engineer and improving the performance of your site is to start by getting the most benefit with the least effort. So that's the cheat sheet, right? If you have nothing else, remember this, I want to put the least effort in to get the most benefit, and that's how I get promoted. So, the trick, beginning web performance. First thing you need to do is start with the real estate. Who's covered that step? Who has a really slow site? Right, so you start with a really slow site. And you want to start measuring. Before you make any improvements, you want to prove to the people who you report to that you have in fact made improvements. So the very first thing you do is start measuring. There's free tools to do that. This is a web page test. Who's familiar with web page test? Right. Those of you who are not, it's webpagetest.org. It's a free tool you type in your website's URL or URL of any page, and it'll go ahead and measure the performance from different. Well, you can select where in the world to measure from, what kind of network connection to use, what kind of browser, and it'll rate your website. So in this particular instance, I used web page test to measure the Meetup page for this talk, and this was the results. It tells you how long it took to load, both on an empty cache and full cache. So it's a pretty good resource. It'll also give you recommendations of what you should change. Then of course you go ahead and change it, measure again, and show your boss, hey, I moved our site from 5 seconds to 4.5 seconds. 10% improvement. 10% more money. So you could use web page test to measure. You could also use RUM tools. In this case I'm showing, this is SOASTA's Impulse product. Specifically it's Impulse measuring, web page test measuring the Meetup page of this talk. Right, so you can measure how long it takes the site to load for actual users visiting the site. So in the case of web page test, it's just a browser running on a machine in an automated fashion, hitting a website, doing measurements. In this case, you measure what real users experience. So in many cases, when your site's already in production, this is a good measure because it tells you what your user experience is and how your users are reacting to that. So if your site's too slow, users might be leaving, might be bouncing faster, your site's fast, then we can tell you at different load times what your user experience, what your user retention is. So different ways of measuring. You can also build your own measurement tools, but it's always easier to use something that's already there. Right. So after you start measuring, what's the thing that gets you the most bang for your buck without doing any work at all? Enable gzip. Who has gzip enabled for their websites? All right. So those of you who don't, turn it on. This is a screenshot from, well, it's a graph from Netflix. When they turned on gzipping, you can see that red line there is when they turned on gzipping, they cut their data center costs by 50%. Simply because they were reducing the number of bytes sent out over the network. Right? Reducing the number of bytes means it takes less time, right? Less time to download those bytes, and so a faster experience overall. And there's absolutely no work, well, very little work involved in turning this on, right? In Nginx, you turn on the gzip on. And in Apache, you turn on mod gzip. There's also other algorithms, deflate, for example, which you can use. So turn on some kind of compression. Gzip is the easiest. Now there's always people complain, sometimes saying turning on gzipping uses a lot of CPU. Right? My web server is the CPU is going to go up to like 60%, 70%, and I don't want to be running that hot. Well, there's a solution for that. On Nginx, there's something called gzip static, where you turn that on, and all you need to do is pre-gzip all your files. So you have JavaScript files, CSS files, gzip them in advance, save them with a .js.gz extension in the same directory as your .js file. And when Nginx sees a request which has an accept encoding gzip header, it'll say, all right, let's see if there's a file that's already gzipped. I'll send that instead without actually doing any gzip. So you gzip only once on your dev box. You can gzip at compression level 9 if you want. No CPU cost. Yes. We used to run this on our servers, and we'd have CPU running at 1% throughout, regardless of what we were serving. So gzip static in Nginx, Apache has a little more complicated method. It's too big to fit on a slide, so Google for how to do gzip static on Apache. I don't know about internet information, so unfortunately. Does anyone use that? IIS? Right. Any idea how to turn on gzipping or gzip static? I would say proxy it through Nginx. So the next one. So gzip is good for static for text files, right? JavaScript files, CSS files, even your HTML, right? If you're writing out HTML from PHP or Java or anything, you can actually pipe it through a gzip stream and get that data gzipped as it's going out over the network. Right? But what do you do about images? So images are something you can optimize in advance as well. There's a great tool called Image Optim. It's for the Mac, but there's also a command line version, and there are other tools. Jonathan, you guys have released one as well, right?
Sorry, what was that?
Image optimization.
Yeah, what about it?
What's the tool that NC has released?
So there's a tool called Wesley.
Wesley?
Yeah, it's my favorite.
All right. So there's a couple of tools. You pass all your images through that, and in this case, I passed the images that I was using for this presentation, and you can see the 27% compression on one of them, 46% on another one. So it reduces the size of your images while maintaining the quality. You can also do things like, in case of PNGs, save them as 256 color rather than 8-bit rather than 24-bit, and gives you much better compression. So these are things you can do in advance. Not much work, right? There's no code to be written. It's just put it into your build process, and then you're done. You don't have to pay a recurring cost for it. And you automatically saved. You reduce the number of bytes you're sending over the network. You reduce the time it takes to download those bytes, and you reduce your data center costs because you're sending fewer bytes out of your data center. Right? So it's straight away cost improvement, performance improvement, and you've done no work. Right? All you've done is flipped a few switches, and that's about it. Now, cache control. Who here has far future expires cache control headers on at least their static assets? All right. So far future expires headers. Now, all this time we've been talking about reducing the bytes sent over the network. The best way to do that is actually not send any bytes over the network. Just have those bytes already in your browser, in your user's browser. So by telling the browser to cache something for a long time, the browser will just not need to make an HTTP request. It'll store that thing in its local cache, read it out of cache, and then present it whenever it's needed. So there's a few things. One is you have to have the cache control header. It has to be set to cache control public. So if it's private, it'll still store it in the browser's cache. The cache control public means it will also be stored in all proxies in between. and set your max age to something large. The HTTP spec says 1 year is the maximum, so I've got it very close to a year. There's also things like the last modified header. You want to turn the last modified header off. Right? Don't have the last modified header, because if you have it on, the browser makes a conditional request with an if modified since and the last time it made that request. Turn that off and the browser will never make a conditional request. Right? It's the last modified header, turn off. And e-tags. Turn off e-tags. Unless your entire website is served from a single box and that box never changes, turn off e-tags. Right? The default for e-tags is to use the inode on the file system. So if your file system changes, your e-tag is going to change, and if you have different boxes, your e-tag is going to change. The browser uses the e-tag as part of the cache key, and so if it sees, it'll make another conditional request saying if none modified and give the e-tag header there. So turn off e-tags as well, and that's a great way to make sure the browser holds something in cache and always reads it from cache until the cache expires. So it turns out that 10 million pies is actually 363 days. Seconds. Alright, so all the beginners in the room, you've now been promoted, you're now an expert. So, how many experts in the room now? Right, if you've just done these few steps, you've actually got an edge over almost everybody else in the front-end world. Right? You're getting much better performance than most websites out there. Because a lot of sites just don't use any of these. Right? User picking is turned off on so many sites. Yep.
But what do you do for cache invalidation? Like, how do you make it?
So there's a few things. So the question was, what do you do for cache invalidation? And typically, if you control the site as well as the assets that are being cached, all you need to do is change the URLs. So use versioned URLs. So when you build your static asset, you attach a version number to the file name or to the directory name. And when you push out a new version, change that in the HTML that you push out. Now, there are other tricks that, so for example, I'm a third-party script author. I also have a JavaScript file that has a far future expires header, but I can't get all my clients to update their HTML every time I change my JavaScript. So there's a trick we use. The JavaScript itself can make a call, can check with the server to see if the version is latest or not. And if not, what it does is open an iframe, load itself into that. So load an HTML that loads itself, and then do location.reload true, which will force a cache refresh on all the assets in that page. Right. It's I've got a long blog post about that. Anyway, that's part of the crazy person talk. Alright, so we're going to get to the expert level now. So what? How are we doing on speed? Too fast, too slow, right?
Okay.
They will be on SlideShare. Once I get home, I'll upload them. SlideShare.net/bluesmoon. Alright. So, CDN. Who uses a CDN? Good. So, using a CDN, you guys are, how come I have their hands up? CDN can do something that you can't do. They can get your content really close to the user regardless of where in the world your user is. Right? So you might have a server that's sitting in Virginia or sitting in Santa Clara, or one or two locations around the world. Your CDN provider will have 180 locations around the world, right? Which each of which is probably how many miles from the user? 500 miles, 1,000 miles? Maybe less, I don't know. Yeah. But so less, 50 miles. So you're reducing the latency between the end user and your content nodes by a huge amount by just getting to a CDN, right? Now, CDNs are great. Most people use it for static assets, right? They'll serve their JavaScript and CSS through the CDN, so the CDN will cache it for them and serve all that content to the user. But you can also serve your root domain through a CDN. You don't tell the CDN not to cache it, but what the CDN will do is open a really fast pipe between the CDN's endnodes and your origin server, and then it can serve that to the user. So you don't have that slow connection from the user to your servers. You have a fast connection between the CDN servers and your servers, which can transfer data in a very high bandwidth. And then that data can get to the user based on the user's bandwidth. Is that one way? So if I make mistakes, feel free to heckle, right? So if you guys have something to add to it, just go ahead. So serving a root domain through the CDN gives you more of a boost than just serving your static assets, right? And make sure CSS is on the same domain. There's a blog post there by this guy named Jonathan Klein. He's hiding in the back of the room. So essentially, your CSS is needed for your page to start rendering. Before your CSS downloads, your page can't be rendered in a browser. Now, for years we've been telling people, and some of the performance rules I put up on Yahoo also say, serve your static assets from a different domain so that you don't pay the price of cookies. Well, now we're saying serve the CSS on the same domain. And the reason for that is, well, you don't pay the price for an additional DNS lookup when you want to load your CSS, which is, CSS is part of those critical assets needed to render the page. So you get rid of the DNS lookup. A DNS lookup could be, in the best case, something like 4 to 15 milliseconds, but in the worst case, it could actually be 60 seconds. And you don't want to have to pay that price, so get rid of that DNS lookup. There's also a cool thing that Chrome does. So whenever Chrome opens, when it loads up a web page, it'll actually open 2 TCP connections to the server. So the first one, it downloads the HTML on, and the second one just hangs around waiting to see if there's any more assets from that same server. And so as soon as it gets to your CSS, it notices it's from the same host. It will download it on that connection where it's already done the TCP handshake. So you're getting rid of that TCP handshake time as well, right? And that reduces the latency of getting your CSS to the user by quite a big amount. And when you eventually move to Speedy, it means that these assets will already be downloaded in the same connection. Split your JavaScript. So, do you remember the rule we said combine all your JavaScript into a single file, minify and gzip it? Well, now I'm saying don't combine them into a single file. Split them into 2 files, maybe 4 files. Right? Put the critical JavaScript, anything that's needed for your page to perform, to actually work, put that into the head and load it in a script node. Right? So you load that in the head, it starts downloading as soon as the browser sees that script node. The rest of the page will block, but hopefully that critical JavaScript is small enough that it doesn't block too long. And you obviously would have far future expires headers than that, so in the most common case, it should already be in the browser's cache. Right? All enhancements, anything that's not needed for the core of the page, but improves the functionality of the page, put in a second file and download that using JavaScript asynchronously, or using the async attribute on the script node. What this will do is tell the browser that it can download this in parallel with the rest of the page. Don't block the page, and whenever it's ready, execute it at that time. So in most cases, your enhancements will just be functions that are executed maybe on page load or on downtown page or something like that. And those don't need to block your site. You can also split it into multiple files because browsers are now very good at downloading things in parallel. So back when we wrote those rules, browsers would only open 2 connections in parallel to the same server. These days, browsers open more like 10 connections to the same server. So you can actually split things into multiple files and download them in parallel. Right? Remember that bandwidth keeps growing. Right? People keep getting faster network connections, but latency does not reduce. Right? Speed of light is constant. The distance from a user to their nearest POP is also fairly constant. So that's not going to get faster. The best thing you can do is mitigate that latency by downloading more things in parallel. So your end-to-end time is less. Audit your CSS. Who uses Chrome? Right. There's this pretty cool feature in Chrome. If you open the web dev panel and you click on audits, right? there's a panel in there, and you can say run audits now, and then it'll give you this thing. So there's something called remove unused CSS rules. And you open that up, and it shows you all the CSS rules that are not being used by the page. Right? It's a pretty good way to say, all right, I've got all the CSS that's built up over the last 3 years of development. What am I using now? Right? Go ahead and check that out and get rid of everything. Now, the one issue is that this is only for this particular page, so you might have multiple pages that use different parts of the CSS. So run the same thing on all of your pages and get an idea of what CSS you're not using, and then just get rid of that. Right? In this case, 90% of the CSS is not used. I mean, imagine the byte savings if we could get rid of all of that. Parallelized downloads. So I already mentioned some of this, that you can, because you get more bandwidth but not better latency. If you notice there, that little orange bar with the second request, that's the TCP connection that Chrome opens when it makes the first request. So it made the first request, the blue, this part here is the DNS request, so it does the DNS once, and then it opens 2 TCP connections to meetup.com. The first one, it downloads the HTML on, and when it's at this point, it realizes it probably needs CSS or JavaScript from the same server, so it goes ahead and starts downloading that on the same connection. Now, if it were not doing this, that orange part would come out here, and it would push this whole thing out maybe 20 milliseconds. Right? So there's some optimizations the browsers do, but you can see here they're doing a lot of downloads in parallel, which is a good thing. Right? If this were all sequential, then their load time would end up somewhere around here. Yeah?
Do you have any recommendation about what file size you should start splitting, for example, JavaScript or text files? Because you want to keep many open connections, but you don't want to make the files small either.
Right. You don't want your files to be too small, because then the overhead of downloading them is more than the file size itself. There's no easy way to tell that. So it depends from user to user. The best way is to profile these things and actually measure it. Right? Try out with different file sizes and measure how long it's going to be. Now, there are some things you should keep in mind. The amount of data that fits in a single TCP packet. So if you're just about going over into 2 TCP packets, it makes more sense to fill up both packets than to actually have one packet that's full and one packet that's 10% full. I'm going to get to that in the crazy person part. Flush early and often. Right. So regardless of which language you use to generate your HTML, well, unless it's static HTML, in that case, probably gets up pretty fast. But if you have any dynamic language, PHP, Java, .NET, that you're generating HTML to send to the client, what you want to do is flush it often and get bytes out to the client. Don't keep the client waiting for bytes to come through. So typically, once you know what the HTTP headers are going to be like, is this going to be a 404 or 200 or something? Once you know that, flush the headers out. If you can flush the doc type and the head section of the HTML, that's good too. The reason for this is, well, there's 2 different reasons. One is you avoid TCP slow start. So I'll talk about that in the next slide. Let's talk about the CSS. So you need, like I said before, you need CSS to start rendering your page. But you don't already have the contents of your page. You're still generating that, pulling things out of the database and stuff. But you already know the CSS that's going to be needed to render that. So tell the browser about that. Send the head section that contains your link rel is equal to style sheet. So the browser sees, all right, I need the CSS, let me start downloading it even before the HTML is ready. So the browser started downloading the CSS, and once the HTML is ready, it can render it immediately. It doesn't have to wait longer. Okay? The other thing is with TCP slow start. So this is how TCP generally works. The browser sends a SYN packet to the server responds with the SYN ACK, and then the browser sends an ACK along with it. So typically with TCP fast open, which is the default now, the first data packet will go on the ACK itself. So the browser will send its GET along with the ACK. Now what happens is, the way TCP works is it'll say you need an ACK for every bunch of packets that you send through. If you don't receive an ACK, it means the other end either did not receive the packet or there's something wrong with the network and it can't handle things so fast. So by default, that's it used to be around 3 packets. It's now set to around 10 packets. You send 10 packets and then wait for an acknowledgement. So what's happening is, while you're waiting for that acknowledgement, no data is going through on the network, right? Now, if no packets actually come through and no acknowledgements come through, the end that's not getting data thinks that the other end can't handle transmissions that fast. So it's going to start slowing down the rate at which it sends data, which means it's going to start reducing that window size. So instead of being 10 packets, it's going to go to maybe 5 and slower. Whereas if it actually does receive data, it's going to start increasing. So that's something called slow start, where you start slow and start increasing, and there's congestion control where if it's too large, it will start reducing. Right? Any TCP experts want to differ on that? I sometimes get that right, sometimes get so sending bytes as fast as possible starts to avoid that problem. You get bytes to the user, to the browser and the server are now in agreement that this network speed is good enough for both of us, because we understand both can send data across. Servers receive that GET request, the browser's got some data back, so it knows that the server can handle the speed and will not downscale the speed. Right? So these number of packets that can be sent before an acknowledgement is received is required. It's called an initial congestion window. And just a couple of years ago, so 2 years ago, it used to be set by default to 3. Unless you were a CDN provider and knew better, in which case you tune all your servers to set it by default to 10. I think Akamai was one of the first to actually tune it up, and none of other CDNs followed. But even if you're serving from your origin or serving from any other place, it's a good idea to turn this up. There are ways to check it, so there's a blog post here on CDN Planet that tells you how to find out what your initial congestion window is on your server and how to tune it. Right? I'm not going to go into the details of that, it's pretty detailed. Any questions about this before we move on?
When you say flush the
Yeah.
head back from the server to the client, what exactly do you mean by that?
So, for example, in PHP, you might just call the flush command. So whatever's in the output buffer right now, send it over to the client. Right? In Java as well, there's a response.flush, something like that.
Yeah, if you have gzip turned on.
Very good question.
Okay.
If you have gzip turned on, what do you do? How do you flush? So gzipping, you can also do chunked gzipping, right? So what happens is when you're ready with a chunk of data, you say flush it, and then it only gzips that chunk and sends it across. So it sends a chunk start and chunk end marker, and then you keep sending chunks that are individually gzipped. So you're not gzipping the whole content, but you're gzipping individual chunks.
So you got to figure out what your sweet spot is, because the gzip algorithm itself isn't as efficient if you're doing smaller chunks.
Right.
You know, the most efficient thing for gzip is the whole thing, but you got to figure out what you're fixing.
Right. Exactly, it's a trade-off between getting efficiency out of gzip, getting bytes to the client first, getting the number of bytes that would fit within a TCP packet after gzipping. So again, it's a matter of trial and error. But these are all things you can do in development before you get to production. The server you use in development is no different from the one you use in production. So try before you push it out.
Does the flushing effect, if you have, even with using a CDN, or doesn't the CDN take care of?
So you still want to get data out to your CDN, right? If you're going to spend, let's say you're doing an expensive database job, you're doing a query which is going to take 3 to 5 seconds to run. You don't want to wait, you don't want anyone in the part to wait 5 seconds to get the head, which is something that doesn't require database time. So you send out that head and then you can do the next flush at the end of the day and you've got everything ready. So there was this, when 9/11 happened in 2001, CNN had to fit their entire website. I got that from this guy's talk. Their entire website in a single TCP packet. And you want to tell us some more about that?
Sure. So on 9/11, they had to fit. Basically, their servers were completely cloud. They have, they gave up on trying to do images. They grew to anything. Like, how do we get the news out? And their director of network engineering said, get the payload under 1,400 bytes. Because 1,400 bytes plus headers would fit in the typical MTU, a typical TCP connection, I think around 1,500. So they made it so that they could serve a web page in a single packet, which took enough load off their routers and their web infrastructure, because every packet needs CPU to actually construct the packet, that they were able to keep their service up and keep the news out. So every byte does count.
So that's part of the crazy person part.
That's crazy.
Another interesting setting that most people have on actually. So netcat.db folder TCP slow start after idle, which is basically says if a single TCP connection goes idle, it'll reset its slow start timers. So you don't want that. You want to turn it off so that if your connection is idle for a while because traffic's going through, it'll still use the congestion level of the packet, the congestion window size it was at before it went idle. Two things you could get for free: mod paid speed for Apache and Nginx paid speed for Nginx. They will enable paid speed automation for your website. So paid speed service. This is not the paid speed tool that analyzes the website. This is paid speed service. That will go ahead and modify your website to optimize the way assets are sent across to the user. So it might take care of all the caching of your JavaScript and minification, compression, all of that stuff. So you get it for free just by installing these modules. But you can do additional things, additional configuration within the modules. Reading the docs is highly advised. This is even beyond being expert. Alright, so at this point, I want everyone to relax. You're no longer an expert. We're now getting into crazy land. So who feels they're a crazy person now? Maybe after you go and implement all of this, there'll be more hands up. Alright, so exercise. Get us sort in ascending order of signal latency. So to make it easier, let's say, like, which one's fastest? Which has the lowest signal latency from these five?
Oh, wait.
Okay, who says light through fiber on that first? Hands up for light through fiber. Alright. The other one I heard was pulsars. Any else? Anyone else?
Lowest latency, smoke signals.
Smoke signals, lowest latency? Alright. Who says smoke signals?
Wait.
Alright. Anyone for station wagons? What about, what is it? Electrons through copper. Anyone thinks that's the... Alright, so we've got a few options. We've got either light, pulsars, or smoke signals as the lowest latency. What would be next? One of the other three.
Electrons through copper.
Electrons through copper. All right. Anyone else? All right. What would be the slowest?
Station wagon.
Pulsars.
Yeah. All right. So.
We're the crazy person on this.
So pulsars are actually the fastest because they light through vacuum.
Right.
Smoke signals are second, light through air. Electrons through copper and light through fiber both around 66% the speed of light through air. So that comes next. And station wagons, highest latency, probably highest bandwidth. Considering you can now get 128 gigabyte micro SD cards. You'll probably get, I don't know, a few terabits a second from New York to Los Angeles. Of course, it takes more time to actually load those SD cards than it does to transport them across the country. So anyway, that's so you want to study real user data. So at this point, any questions before we go further? All right. So you want to start studying real user data. You get run data. You start looking at your access logs. Look at patterns that requests are coming in through, and try and figure out potential places to parallelize, predict, or cache. Right? This is something that we learned from CPU design in the 1970s and 80s. Right? The way to make a CPU faster is to parallelize operations, predict what's going to happen next, and to cache any data that you need. So, parallelize, we've already seen different ways when you can split your content into different files, download them in parallel. Caching, we've also seen. Let's look at prediction. So, preload. One thing you can do is prefetch assets required for the next page in a process flow. So looking through your access logs, for example, you know that our users go here, and then they go here, and then they go here. And so I know if they're on page 1, there's an 80% probability they're going to go to page 2. So let me download all the images and CSS and JavaScript needed for page 2 after page 1 is finished loading. So in the onload event of page 1, I'm going to download all of those things. How do you do that? It's fairly easy to download images. Create a new image object in JavaScript, set the source to it, and it downloads. CSS and JavaScript are a little more complicated. You could create a script node, but once you put it into the page, it's going to affect the page. So typically what I do is create an anonymous iframe and inject HTML into that iframe that loads the CSS and JavaScript. So it loads it up, it'll cache it, but it will not actually execute it in the context of the current page. You can use various browser hints to tell the browser to preload or pre-render several assets. So I'll go through them from bottom up. Link rel DNS prefetch. A DNS prefetch is something that's supported across most browsers today. What it does is you put this in your head. Let's say you've got certain images or other assets that you're going to need on your page, but they're going to be needed further down on the page. What you want to do is you want to tell the browser stop doing the DNS lookup now itself, so that when you need that, you can skip that DNS lookup and just do the TCP. So you put this in your head saying link rel equals DNS prefetch and put a URL. It doesn't have to be a URL that's on your page. This has to be the same domain of an asset that you're going to need. So the browser will start doing the DNS lookup at this point itself. It'll do it in parallel with the rest of the page. When you come across that asset, you can download it faster. Link rel equals sub-resource is something, yeah.
Someone advised me to hard code the IP address of the other domain instead of...
So that used to be in fashion a while ago. The problem is if you have the IP address here, you have no option of ever changing that IP address. Right? You're then dependent on routing rules and stuff. You can't do geo-based load balancing. So using a host name is better for many reasons, apart from just the fact that humans can't remember IP addresses. But these are ways that browsers offer you to get around the problem. Link rel equals sub-resource says that this particular URL is something I'm going to need on my page later on. I don't need it yet, but I will need it. So what the browser will do is it'll then put it into its sub-resource queue. And whenever it's not doing anything else, so let's say it's already downloaded everything that's on the page, JavaScript, CSS, that it's seen so far, it's still downloading the HTML, but it's not doing anything in its background threads. It'll then start downloading these sub-resources. Right? It won't execute them, it'll just download them and hold them in cache. Now, there's some, I think this is only supported by Chrome, I'm not sure about other browsers. Anyone know different? So there is a bit of a bug in this, in the sense that if you have this link rel sub-resource and it starts downloading, but then it sees the asset before it's completed downloading, it'll abort that first download and then start a new download. And this doesn't happen all the time, so I think there's some beta version of Chrome or something that has the bug and it's probably fixed. So you'll want to test that before you go ahead and implement it in production. Link rel equals pre-render is something I like. It's been around for 2 years in Chrome as an experimental feature. And in fact, Google the search results page uses it. So what it does is it tells the browser, or Chrome specifically, go ahead and download this page, this entire page, all the assets on the page, and render it, execute the JavaScript, do everything that's needed to draw the page in a browser, except don't draw it in the browser. Draw it in an invisible tab that's only in memory. And then if the user clicks on the link that matches this URL, immediately make it visible. So you get load times of like 1 millisecond. And that's pretty cool. Yeah.
How does that affect analytics? Not just Google Analytics, but...
I don't know how it affects other analytics, but Boomerang, the tool that I built, takes that into consideration. So there's a special event that's fired on visibility changed. And there's also a document.visibility, document.visible, something like that, which has 3 states. By default, all other browsers, it has 2 states, visible and hidden. So this is a standard feature, by the way. If a page is open in a tab that's not visible, then document.visible is actually set to hidden. So you know if a page is currently being seen by the user, or is in a background tab, or even it's in a window that's minimized or hidden by another window, it still says hidden. Chrome added another option to that saying pre-rendering. So you know that it's been pre-rendered, the onload event is fired, everything is fired, so the page is now ready to be used, but it's not visible to the user. So what we do with Boomerang is we detect that onload is fired, but the visibility state is set to pre-render, so don't send any analytics yet. Wait until visibility changes it to visible or hidden, which means the user specifically clicked on the link to open it, and at that point we'll go into fire analytics. Yeah.
Yeah, so that URL can be anything. It can be a page, it can be an image, it can be...
Sorry, didn't get that.
Can it only be a page, or can it be anything?
It can be anything, but you don't get the benefit by having something that's not a page that has a lot of work to be done. If you adjust the static results, you could use link rel equals prefetch, which is supported across more browsers, and it just means prefetch it and store it in cache, but don't do anything. Yeah.
But this is based on the page that you're pre-rendering, mostly static, I think.
No, it doesn't need to be static.
So when user switch to that tab, or make it visible, you want some part of it maybe refreshed or so.
You may. So that's what you do is you attach the on-visibility changed event.
Oh, so
and that event will give you a state saying this has gone to visible or hidden or pre-rendered. By default, it will be pre-rendered, and it will change to visible or hidden. You can also use that to, let's say you have some animation on the page, and you can trap that event. If it becomes hidden, you can stop the animation, because you no longer need to do that work. Some browsers will also slow down the least, increase the least count of the timer. So if you do a set timeout, by default it can fire every 15 milliseconds or 4 milliseconds, depending on the browser. It'll make it slower in its background time. Yeah.
If the user clicks up to go to the URL halfway through the rendering process, does the page keep rendering from the
Yeah, so it'll just continue downloading or rendering from where. So there are actually a lot of bugs when they first introduced it. They've all been fixed now, so now if the user clicks on it, it'll actually do the right thing. It'll continue from where it was in there. Yeah.
And if it's a dynamic page that is affected by things that you're doing on the current page, can you cancel the pre-rendering?
No, I mean you need to tell it. So you specifically put that tag in there. So you'd only put it there when you think you're ready to download that. Okay. Now the Google search results page is one example where you can't. So what they do is I don't know if they do that in every results page, but in many cases the first result they'll pre-render that. So whatever was the first search result, they'll have a link rel equals pre-render for that. And you do that when you know your process flow. Yeah. At the back,
right? Does that mean I can dynamically add the pre-render tag later on?
You can, yes. All of these tags you can dynamically add.
Using the page, I can decide what the next page might be.
Yeah. So all of these you can add dynamically using JavaScript at any time on your page, and the browser will start handling it at that point in time.
Okay. on top of that, can I tell the browser to stop doing this? I can't
Not that I know of. You might be able to remove the tag from the page. I haven't tried that, but it might work.
Will the user be aware that additional stuff is going on?
No.
I understand the page will be loaded, but will they see anything that's like...
No, no, not even in the web development tab. So you don't see any network activity. If you're running a network sniffer, yeah, you will. There was another hand up there.
Are these only in Chrome or are they?
This is in all browsers. This one I'm not sure. That one is only Chrome. There's also link rel equals prefetch that is all browsers.
How many of these optimization tricks, I'm new to the mobile space, so you have to forgive me, can be used in hybrid mobile apps, since they run in sort of invisible browsers
Yeah.
in the mobile device?
So, if you're using it in an iOS, you're most likely doing a Safari-based browser, which means probably none of it will work. If you're doing it in Android and Chrome, all of them will work.
Okay.
Right. There was another hand. Right, just put your hands up whoever has questions.
So what are the limitations of this? What's stopping me from pre-rendering my entire site?
You may not want to actually download it. So there are many sites that will actually do things on the server, so when a request comes in, you might change state on the server. You may not want to do it in that case. Typically, you want to do it for requests that are endpoint. Did I get that right?
Yeah.
So that
If I have a full static site of like 1,000 pages, there's nothing stopping me from just hitting
there's nothing stopping you, but then you're probably killing the user's browser. So you start downloading all of that.
Just rendering takes CPU.
Yeah, it takes CPU time. It's not rendering it, but it's still doing all of the work necessary to render it.
Do you know if there's any limitations on cross-domain issues?
No, you can do this cross-domain. That's how Google loads the first search results.
Are they parallelized? Okay.
Yeah, so it'll do it after, when it's got nothing more to do for this page.
Yeah.
So one thing, it'll never actually penalize the parent page for doing any of the pre-renders or prefetches. If anything else in the current page comes up, that'll take precedence, the other thing will stop. So if you're doing a DNS prefetch and it started that DNS, well, that's a bad example, so that's asynchronous. Let's say subresource, it started downloading and now something else had to be downloaded, that new thing would take precedence over the subresource. All right, any more questions about these three?
If you have a pre-render on a page that's pre-rendered, is it?
No, it won't do anything yet, so it'll wait until it's visible. But again, they might change it. So this is not a standard W3C spec. It's the Google proposal to W3C, so they could change it whenever they want. There's a pre-render, a Google group specifically for pre-render. If you want to discuss it, it's about 30% spam, but yeah, 70% signal. Any more questions? Should I go to the next slide? I think I should do a talk on this slide. Another thing you can do, so all this time we were just talking about preloading the next page's stuff on the current page. You can also post-load the current page's stuff after the page is loaded. So if you have a carousel, you only need to show the first image. Probably you want to download the second image inline in the page, but all of the other images, download them after onload or after you've finished downloading all the critical parts of your page. And similarly, if any component that's maybe below the fold are invisible to the user on the first view, you can defer loading of those assets until after the onload event is planned. So there are some examples of sites that only do downloading after onload. Google Maps, for example, the initial page load only has the JavaScript necessary to download the rest of the page. And once the onload files, it will start downloading whatever is necessary to render that view, depending on what your geolocation is. And then as you keep moving around, they'll download. Any questions about post-loading? Alright. Detect broken except encoding errors. So this happens, it's less frequent now than it was 5 years ago. but many Windows antiviruses and firewalls, in fact, will disable the accept encoding header because they find it hard to analyze gzipped content. Right? So what they'll do is they'll change accept encoding to accept encoding. They'll change the C to a D, or change it to an X, or make it all X's. But you typically know because they have to maintain the same length. You can't change the length because that will break the content length header. Okay? So you do some analysis on the headers if you notice these things, and I've got a blog post listing about 27 different types of modifications to the accept encoding header I found. Detect those and gzip anyway if you see any of those. Okay? So by default, the server will not gzip unless it sees accept encoding gzip. But if you notice this header being disabled, go ahead and gzip the content anyway. So this blog post has links to other resources that you can use. Basically an Apache config file that you can just drop into your web server to do this for you, and similarly for any links. This used to be around 15%. 15% of our requests had this thing broken 5 years ago. When I did the test last year, 2 years ago, it was around 3% or 2%. But that's, when you're dealing in millions of page views, that's still a significant number. Alright, prepare for HTTP 2.0, speedy. Not exactly the same thing, but close enough. So, multiple assets downloaded on the same connection, and TLS is on by default. That breaks many rules. So one of the things that HTTP 2.0 will do is it will try and download your HTML, CSS, and JavaScript on the same connection, but it can't do that if they're on different servers. They have to be served from the same hosting. Except there's a little bit of an interesting thing, like if you have different host names where they all point at the same IP address, and the SSL certificate has a wildcard for all of those host names, then it will still be able to download all. Does that make sense? A little. So let's talk about how HTTP 2.0 works first. It sees an HTML page, downloads that page. Right now it's seeing all the assets on the page, CSS, JavaScript, images. It'll just open a single TCP connection and make all those requests on the same connection in the order that, all at once. And then it'll start getting responses all in parallel on the same connection. Now it knows how to connect each response to a request, right? Some form of pipelining that it does. It does all of that intelligently. Now it can only do this for multiple assets if all those assets are on the same server, so it can make one TCP connection. If they are different servers, it has to make different TCP connections. So what you want to do then is, even if you use different host names to have a cookieless domain, for example, you want them to point to the same IP address and have an SSL certificate that includes both host names. So only if you do all of those will you actually have all your assets downloaded faster using HTTP 2.0. There is, of course, a downside. There are several consumer-grade cable modems, DSL modems, that think that the client has been compromised by a worm and is DOSing the server if there are too many TCP connections open to the same IP address without an acknowledgement coming back for all of them. So I think HTTP 2.0 should take care of that because it's only opening a single connection. But for clients that don't support HTTP 2.0, you will still have multiple host names pointing to the same IP address. So that cable modem, which only sees the IP address, thinks you're trying to DOS that server and might block this connection. So experiment. Buy a few modems and try it out.
When is HTTP? Maybe this is a dumb question, but when?
So Chrome and Internet Explorer 11 or 12. Do you know which version?
Yeah, 11 has a spec.
Yeah. So they already support it right now. Servers can already start supporting it using mod speedy, for example. Or is there a separate mod for HTTP 2, or is the speedy mod just going to be
For Apache?
Yeah, both Apache and Nginx.
Actually, it must be Nginx.
Nginx, yeah. So Nginx you can just turn it on. It's called Speedy, SPDY, in most servers. Although Speedy is technically slightly different from 2.0, it's just going to become HTTP 2.0 language. So yeah, you can use it today. There are browsers that support it, and if you're in JavaScript and you want to detect if you're running through Speedy, there's hang on, I'll check my source code. Yeah, there's if you look at the performance timing, so window.performance timing was fetched via Speedy. There's a flag in there that's either set to 1 or 0, or it doesn't exist for browsers that don't support Speedy. Then you'll know if that page was downloaded with Speedy or not.
There's also a pretty good Chrome extension called Speedy Check, and there's a lighting bulb in the location bar.
I'm talking more about detecting whether your end user received the page via Speedy or not. And you can use that for your analytics. Boomerang, for example, was collected and sent to your analytics. All right, any more questions about this? Be aware of third-party single points of failure. Right? Who uses third-party scripts or images on the site? Facebook, Twitter, Google Analytics, Impulse. All right, so try this out. Right, whenever you try and edit your EDC host file, that's at least on Linux, FreeBSD, and Mac OS. Windows also has a host file, but it's not in EDC. It's somewhere else. I don't know how. I could Google for it if I have. Set the third-party hosting to point to the IP address of blackhole.webpagetest.org. So this is something that Pat Meenan set up. It's basically an IP address that will do nothing. It will just not respond, right? Or it'll just wait for a long time and time out. What you do then is you set that host name to point to this IP address, and then visit your website and see if that breaks your website or not. Right? Typically, if you have something loading inline, that's going to block the page from rendering. Right? Just this afternoon, I went to a news site, and I was just waiting on this blank site. The header had loaded, and the header image, and some square had loaded on the left, and then it said waiting for analytics.google.com. So I hit escape, and then the rest of the page magically appeared. Well, basically, I was waiting on CSS, which was waiting on this JavaScript to load. So you'd know whether any assets that are not under your control have the power of taking your website down, or at least making it not display. So a lot of assets do that. There are ways for a third-party script author to get around that. For example, the way we do it with Impulse, that is documented here. So anyway, understand how to use Black Hole. There is a blog post that Pat Meenan wrote about the whole process for understanding third-party single points of failure. And lastly, understand the iframe loader technique. And that's a technique that I came up with along with Stoyan and guys from Nebo and stuff. A way of downloading JavaScript or any other assets, taking them out of the critical path. I did a talk about that at an earlier meetup. But anyway, there's a blog post about that, documenting the whole process. It basically stops your script will no longer block the onload event. So download in parallel. If your server is offline, it doesn't affect the page or anything. And that's, I think all third-party script authors should do that. And finally, can you predict round trip time based on the different parameters that you know about your web server? So anyone want to memorize this? That's all I have. So there's a lot of references in the slides. I'm going to post them online. Slideshare.net/bluesmoon. Any more questions? Yeah.
This is a really beginner question, but in terms of fetching the assets after you load, what's the best way of doing that with like lazy loading?
Yeah, so there are images you can just load in JavaScript. Scripts and CSS, the best way is to create an iframe and load it in that iframe. So you can either have an HTML page on your server that references all the assets you need and just load that web page in an iframe. Or you create an anonymous iframe, set its source to JavaScript :false, and then write HTML into that. So you get a handle to the document object and write HTML. Yeah.
You mentioned sprites.
Yeah, I didn't mention sprites because I was giving everyone. It's just another way of. Is anyone not familiar with image sprites, CSS sprites? So here we are. Yeah.
So if you're using iframe loader technique to get, let's say, JavaScript into the page, is the parser thread firing when you load it, or is it just holding onto the file itself and will only actually parse on the script tag?
So the way the iframe loader technique works is it creates an anonymous iframe, sets its source set to JavaScript :false, and then on the onload event of that iframe, it'll start downloading the JavaScript. So you inject script. So the parser will run at that point in time.
Okay.
Now the thing with iframes is it does they can run in parallel. So JavaScript can run in parallel in an iframe as with the parent page. Same way as different tabs run in parallel. Okay. So you do get a different JavaScript context, but you can access global variables and stuff.
Okay.
You're not technically running like in a multi-threaded fashion, so they're not two things running in parallel. So you want to do JavaScript running in parallel, but it can run while other things are happening in this page, not other JavaScript things.
Okay, that's what I was concerned about. Is that you end up with you end up blocking JavaScript.
So typically, what we do with Boomerang at least is it just loads the JavaScript and it'll actually execute it on an event that's fired after when it's ready. Okay. Right? So it won't actually execute anything while it's going through.
So basically to track like when all these assets, like say you're loading with this iframe to beat assets after the fact, when everything's downloaded, you're done and your user has everything.
Yeah. So typically with the iframe loader technique, the onload event is going to fire way before this loads. So you need an onload event on each of them. Typically, if you're loading your own JavaScript, you can fire an event at the end of that JavaScript, which is a standard way of doing it.
So if it's CSS assets or something, you wouldn't?
You typically won't use download CSS this way because the CSS can't affect the page. So you'd only do it if you wanted to preload it from the next page, in which case you don't really care if it's loaded. So JavaScript is the only case. Images you might do it. In fact, so CSS, I think you'd definitely not do it because you don't want to pull CSS in after the page is loaded. It causes a full repaint and stuff. But images, for example, you might load them in an iframe and then pull them in via JavaScript. And then you could just do that in the current frame as well.
Just like in JavaScript where you might want to do some stuff in the head that you absolutely need to do.
Yeah.
And then the rest, wouldn't you want to do that with CSS, or did you already need to?
No, there's some things you can only do in JavaScript.
Right, but the rendering time of that, of the fold, couldn't you split your CSS up?
Oh,
the minimal amount of CSS, and then...
You might have to test that out, but I know that generally whenever you change the CSS of the page, it forces a refresh of the whole page. A repaint, so which may not be what you want, because none of the CSS that you load after the fact may not affect any of the components about the fold. But because of the way the browser calculates what has to be rendered where, it may still need to repaint it. Just because it might have more things on it. Any other question? All right. Thank you.